The first thing we'll want to do is install globally the NativeScript package. This will give us the TNS command line utilities that will allow us to create an app. In this case, we'll call it ngNative, and we'll pass the --ng flag. And if we take a look at what that generated for us, you'll see that we have the standard setup for a NativeScript Angular app. We'll spend all of our time inside the app directory, where you can see it generated an app component for us. This is a standard Angular component. And then you can see in the main TS file where we have an ng module that declares our app component, defines it to bootstrap, and then imports the NativeScript module, which comes from the NativeScript Angular plugin. It happens to override a couple core Angular modules to provide some NativeScript specific functionality. And lastly, you can see the platform NativeScript dynamic method that is imported, which is used to bootstrap our app. To run our app, we can use TNS emulate iOS. And our app launches on the iOS simulator. We can see that we have some basic data binding going on in our example. And you can see that this is a native UI button, and these are native UI labels on iOS. You may often want to preview your app on a different emulator or device version. And you can see what options are available on the Mac by running xcrun simctl, which stands for Simulator Controller, and then list. This will give you a full list of all the options we could use. For instance, if we wanted to preview on the iPad 2, we can just copy that name, then run tns emulate iOS and pass the -- device flag, and then in quotes we can paste the name. And when our app launches, you may notice that it is huge. You can go up to the menu under Window and choose Scale, and you can adjust that to 50%, for instance, to actually see the app inside that device. Feel free to adjust that scale for whatever screen resolution you may be on. Let's use the Android command line utility to launch the SDK Manager. This will give us an opportunity to install different versions that we may want to set up emulators for. Now we can launch genymotion and add some virtual devices. I have a few added here, but we could add some more by choosing Add. We can choose the Android version that we'd like or the device model and add that device. You may also need to check your settings, and the ADB tab may need to point to your specific install location for the Android SDK. In my case, I installed it using Brew, and so we can see that it points to the seller location for my SDK install. But this can be any location that you have the SDK installed. Once you have a device added, you may want to check the settings and ensure that the Use Virtual Keyboard for Text Input option is on. It's often the case that when you click inside an input and type into it, you may need to use some special characters that are only accessible through the virtual keyboard. Double-clicking that will launch that emulator. Once the Android emulator has booted up, we can now go to our project and run tns run Android. And we will see our app launch now on the Android emulator. You can see it takes on the native characteristics of Android using the native button widget and the native labels. And of course our data binding works the same, and you can also see that we get the nice wave effect on our button clicks. You can see in our components view template the fundamental building block for a NativeScript view, and that is layout containers. You can think of them kind of like divs. But the stack layout can be used to stack things on top of each other vertically. And if we wanted them side by side, we could set the orientation attribute to horizontal. Another type of layout container is the grid layout. You can define how many rows the grid has and specify how you want the height set, and then specify how many columns it would have, in addition to the widths of those columns. And then lastly, your components inside need to specify which row and which column they pertain to. And this one here would be column 1 because our columns are 0 index based. And you can see we get the same layout that we had with the stack layout set with its orientation horizontal. But with the grid layout, you get some more flexible options. Instead of auto, we could specify each of our columns with a star to have them stretch. If you wanted precise widths here, you could also specify the exact width. You can also add spacing in between your columns by specifying a star to stretch fully between them, and then specifying this column to be the last column in the stack. To see that a little better, we'll just add some background color. And you can see it's 100 wide, and by default it is text aligned left, but we can adjust the text alignment to be to the right. I'm going to set these both back to auto, and for now I'm just going to remove the background color, but we could also specify our row height to be precise. Let's say 200 in height. And we can see by default the vertical alignment on these labels is centered, but we could also set that vertical alignment to be at the top, and we could apply the same thing to the other label. The real power in NativeScript XML is its ability to abstract each platform. Here's the same code we've been writing on Android, and you can see the same layout. These grid layouts, stack layouts, labels, all the NativeScript XML represents the native widgets on each respective platform. So on iOS, we have a native UI button, and on Android, these are the native button widgets. One thing of note is that we're using all caps on this button here. But if we were to use standard caps and take a look, you'll see that on iOS, it actually does respect that proper capitalization. But in Android, because the native button widget always displays all caps, you can see that we retain that native widget characteristic. It's important to note that when working with NativeScript for Angular that all of your XML components must be properly closed. You cannot use a self-closing tag here because that will actually cause an error and likely your app to crash. The reason for this is due to the parse5 DOM adapter that the NativeScript Angular renderer uses when it parses the view, and that is also why the .html extension is used instead of XML. If we look at the app.css file in our project, we'll see a default setup here, but let's back way up. With no styles applied, we can see that our layout containers just position our components on the page as is. Let's start by adding a custom class here called heading. We'll give it the color purple, and we'll also set the padding to 10. And let's apply that class on both of our labels here. And we can see that class applied, purple, and we've got our padding of 10. We can also take these inline attributes and apply them to the style, much like you could with inline styles on a DOM element. So let's add here vertical align, and we'll say top. And we can see our labels are still aligned to the top. We can also remove text alignment right and apply that to a new class that we'll call text right. And we can see our label is still aligned to the right. And just to prove that's working there, let's set a background color to yellow. And let's also set an explicit width here to 200. You can see now that we have width of 200 on our label, and it takes into consideration the padding of 10 that's coming from the heading class, which is also on this label. Additionally, note that because this column width is set to auto, it's allowing that 200 width of that label to expand. Our grid layout, though, has ultimate say. We could set 100 on that column width and ensure that everything in that column position is restrained to 100 in width. You may have noticed that I am omitting the PX, which is often customary in DOM styling. The PX for pixels is actually ignored with native styling, so if you have it, it is okay, but technically you do not need it. Native views support a few extra properties that are not available in DOM styling. Let's add a class of top grid to our grid layout, and let's define a top grid here, and let's say our width is 200. We can see that positions the grid by default in the center. However, one native property that is not available in the DOM is horizontal align, and we can horizontally align that layout container to the left. The CSS you get out of the box with a new project gives you two directions to go. You can create your own classing structure or build on top of the core theme that is installed by default. Let's look at what this core theme has to offer. In our view template right off the bat, you'll see some classes here just to give you a hint. P20, if we remove that, is what's actually providing the padding around this main view here. There are padding and margin classes that range from 0 up to 30, going by 5 increments. So we could say P5, and that would actually give us a padding of 5. We could also use margin and 20, and that will give us a margin of 20 around that container. We could also just provide margin left of 20 or margin right. These utility classes exist for padding and margin as a nice simple convenience. There are also the heading classes ranging from H1 all the way up to H5. And then there's the text left and text right and text center classes. There's also a collection of button styles, much like Bootstrap. In addition to button primary, there's button outline. If we go back to button primary here, this button active class is what gives it that slight color change when you tap on the button. You can see that present here on Android. But if we remove that button active class, you can see that it will retain the standard highlight behavior for the platform with, of course, its unique characteristic. On Android, you get the wave effect, and on iOS, the default tap highlight behavior. There's a couple extra utility classes like button rounded, SM for small, or LG for large. And you can see that retains the same look on Android. A couple handy classes exist for dividers like HR light and HR dark. And we could add some margin to the top and bottom by using margin Y 10. That will apply 10 margin to the top and to the bottom of that divider. In addition to the light theme, there is also a dark theme. You'll notice that when applied by default, you'll get the dark theme applied to your action bar, and of course your page is still white. You'll want to be using the page class on your root element layout container to actually get that applied to your whole page. And notice our HR dark divider is hidden, so we could use the HR light class here. For a faster development experience, we can use TNS livesync, and then the platform you would like to livesync on, in this case we'll use iOS, we'll pass the -- emulator flag and then -- watch. And we notice now if we make a change and save, you'll see it live reload over here. You can also run the same command against Android, and that will run against any Android emulator you have running. And we can see that now live reload on Android. In addition to Android and iOS specific options, you can omit the emulator flag, and that will actually run live sync on any Android connected devices and emulators at the same time. Same goes if you use iOS. That will run on any connected iPhone and if you have the emulator running. You can also omit the platform name altogether, and that will run live sync on all connected devices and emulators. If you just wanted to run live sync on the Android and iOS emulators at the same time, you can use TNS live sync with the emulator and watch flags. And now when we make a change, we'll see them both update in the iOS emulator and in the Android emulator as well. To set up routing, we're going to start by replacing our app component template. Instead, we're going to put one stack layout with the page router outlet inside. This will serve as the main spot to insert our routing configuration. We now want to add some components to set up for our routes. Let's start by organizing a bit and add a components directory. And inside that, we will add a home directory to place our home component. We'll just have a standard Angular component pointing at a template. And our template will start with a stack layout, and we'll add a grid layout to house just a couple navigation buttons. We'll have a dashboard route and an about route. And then we're going to add a stack layout here to house our base router outlet. So the base router outlet is the standard directive from Angular, and this is what's going to load in our flat routes. So the main difference between router outlet and page router outlet is the page router outlet is going to push on pages onto the navigation stack on the mobile device, and the router outlet is simply going to replace our components in this section. So let's now add our dashboard and about component. Let's add a dashboard folder and an about folder. And our about component is again going to be a simple Angular component pointing at a template, and we'll just add a stack layout. And we'll add an NS label. We'll just say about egghead.io and class it with an H1. And we'll just add another NS label, and we'll class this with an H3. And for our dashboard component, we'll again have a simple Angular component pointing at a template, and we'll place another stack with a label, and we'll just say cool dashboard. So to review, we have a dashboard component now, an about component with some labels, and our home component which is going to link to our dashboard and about route. So let's add that now. So we're going to use the NSRouterLink directive, and this is going to point to our routing configuration for the dashboard. And we're going to set this up to be home. And for our about route, we're going to use the same directive, but just to show you the alternate, you can also use NSRouterLink and point it directly to the string. And for this string, we're going to say home/about. So now let's begin to define our routes. We'll start by adding a components module in the root of the components folder. We'll start by importing the NativeScript module, and we'll need the NativeScript router module. And let's import ng-module from Angular, and we'll also import the routes definition from the router. And let's import our home component, and then our dashboard and about component. We'll start by exporting a constant for our routes, typed as routes. We'll start by adding a route path, which is going to redirect to /home. And we're going to set path match to full to make sure it only matches for the route. Then we'll set up the path for our home route as our home component. Then we'll set our children. And these are the routes that are going to load in the routeroutlet directive that is defined on that home component. Our first path is just going to be the root of home, and that is going to be our dashboard component. Then our second path is going to be the about path set to our about component. Okay, now let's set up our ng module. We'll set it to import the NativeScript module and the NativeScript router module. And then we'll want to set our declarations to our components. It's the home component, dashboard component, and about component. Then we want to set up our exports. And we want to export these same components. And we'll just refactor this to be a collection instead called components. And this will make it convenient so we don't have to enumerate through these again. And now we can use this collection in our declarations, and we can also export that here. Then let's also export the NativeScript module for convenience and the NativeScript router module. And let's name our class components module. Now that we have this setup done, let's go to our app module and let's use it. Import components module and routes. And since our components module exports the NativeScript module, we don't need that here any longer, and we can just use components module. And then we'll configure our routes here from the root module. And we no longer need this imported. So just a quick recap, because we've done a lot here. We've got an about component, we've got a dashboard component, and we have our home component, which has the router outlet, which is going to contain the dashboard and about components. And our app component has the page router outlet to house our entire route config. Now let's run this and see what we got. And we can see our home components, dashboard, and about buttons here at the top. If we click on about, that changes the router outlet on the home component to show the about component, and dashboard shows dashboard. Let's add one more component and navigate to that using the page router outlet. We'll add a detail folder, and for our detail component, we'll just add a stack with 2 labels. And now let's add our detail component to our route config. Let's import the detail component. We'll add it to our components collection. And this time, instead of adding a child, we'll add a path at the root of our route config called detail. We'll set the component to detail component. And lastly, let's add a button to our about component to navigate to it. We'll add a button and we'll set NSRouterLink to detail. And we'll just have the text set to read more. And let's take a look at that. And now when we view about, we can click read more, and you can see how it pushes the page onto the navigation stack for our detail page, and we can navigate back. Let's say we want to add an active class when each route is active to these buttons. We can use the NSRouterLink active directive and specify the class that we would like added. We'll say active will be the name of one class, and we can also add font weight bold. This is a convenient class that comes from the default theme installed, and this will bold our text. We'll apply the same style to our about button. And now let's add our active class to the home component itself. And for this example, we'll just say the active class is going to color that button red. And if we run that, you can see that our dashboard button is now active. And when we click on an about, it now activates about, but we have a problem. Dashboard and about now are active. To solve this, we can apply the NSRouterLink active options directive. And we can specify that the exact match must be true in order for this one to be active. And if we look at that, we can see that now solves our problem. Let's say we'd like to add a title to the top of each of our routes here. We could go to our about component and we can drop an action bar and title this about, and we'll do the same for our dashboard. And we'll title this dashboard. And if we take a look at that, we now have an about action bar at the top and dashboard. What happens when we navigate using the pagerouteroutlet using read more to our detail component? You can notice that our back button now says about. We may want this to show different text in a different situation. To manage that, let's go to our detail component and we'll use an action bar, and we're going to use the navigation button. And this is going to set our text to back, so it will replace the about text here and use back instead. And on Android, this is going to use our back menu icon. And let's just set our title to detail here. And if we take a look at that now, when we navigate to detail, we can see our detail title with the back text here now. On Android, however, when we navigate to detail and we click the back icon, it does not navigate back. This is because on Android, the navigation button is handled differently than it is on iOS. To solve that, we want to add a tap event to our navigation button just for Android. This tap will actually be ignored on iOS, and we'll wire that to a go back method that we'll add onto our detail component. And to use this, we want to import from NativeScript Angular router the router extensions. And let's just inject that, and we can use that here to simply navigate back. And with that in place now, when we navigate to our detail component and go back, it now will navigate back. In addition, on Android, you can use the back button. To open a component in a modal dialog, you first want to import from NativeScript Angular directives dialogs. This will give us the modal dialog service. We can inject that into our about component. Let's add a function that will open our modal. And you'll see that we have show modal, and it takes a component type. So let's open our detail component from this about component. So let's import detail component, and we'll specify our detail component to open here. And then it takes modal dialog options. So let's also import the modal dialog options, and we'll define some options here. One of those options is the context, and that's a way we can pass data to our component. Let's just pass a message and say hello. And we'll pass those options here. And that returns a promise that will resolve with data that we could pass back from our modal. So in this case, let's say result, and we'll just simply log the result out here. Now let's just wire up our open modal action. Let's replace the NSRouterLink button, and we'll wire up a tap event to open modal. And when we run that, and we click read more, we get a hard crash. And this is because the modal dialog options require a view container ref to be passed in with the modal dialog options. So let's make that change now. We just need to import view container ref and inject that here. And then we'll pass that along as the option here. When we run that now, go to about and click read more, you'll see our modal open. But interestingly, we have no action bar and therefore no way to close it. So our detail component had an action bar on it, but these are ignored when it's opened in a modal. So instead of using an action bar here, we can create our own, and we'll use a grid layout. We'll set auto on the row height, and we'll have auto, a flexible container in the middle, and auto width on the third column. And we'll just place a button on the left here, and this will become our close button. And then we want to wire up a close action here. And let's set its row position and column position. And then here we'll add a label and this will be our title detail. And let's add a row and the column position here. And let's class this as actionbar. This comes from the default theme installed, and we'll class these as action items, and this will class as actionbar title. Now we need to wire up our close action. So let's add a close action here. We want to import from NativeScript Angular, directives, dialogues, and we want the modal dialog params. These we can inject and then use these to actually call the close callback, which we have the opportunity to pass back data to the caller. So in this case, let's just say that we closed the modal. And if you recall, in our about component, we're just going to log out that result. We also have this message being passed as the context to the detail component. And we can handle that much in the same way with our params. So we can say params.context, and we would have that message available. And let's just console log that, so when the detail component shows, we will see that. And now when we run this and we open, we will get another crash. This crash is actually related to more than one layout child inside a content view. So this is coming from our detail component here, and if you notice, this is using a grid layout and a stack layout parallel to each other, which is not allowed. So we want to wrap this inside of a stack layout and take these two layout containers and put them inside. So there needs to be only one layout container at the root. This is different than when there's an action bar. You can have an action bar above that is parallel to your main layout container. Now if we open the modal, we'll see we have our action bar here from the grid layout. The action bar classes just provide coloring and bolding on the action bar title. So let's just add a little bit of spacing to make that look a little bit better. We'll just add P10, and on our action bar title, let's make sure that it is text center. This time when we take a look, we'll see it's looking a little bit better, but our detail is still not centered correctly. And this is because the grid layout, we have a third column here set to auto with nothing in it. So this flexible container is actually stretching across both column 1 and 2. So we have two ways we could go. We could end up adding a third button if we needed that in the third column position, or we can use exact widths on left and right columns here, and let's just say 75. And looking at that now, we can see we have a nicely centered title here. And when we close the dialog, we can see close the modal dialog options, and when we open it, we can also see the hello that we're passing to the detail component. And on Android, we can see the same behavior, a native Android dialog open, which also closes the same. To display a list, you may usually use an ng4 for that with Angular. NativeScript provides a powerful component for this called the listview. So instead of the stack layout, let's drop a listview in here. And it provides a lot of events that we can wire into. But for this example, we're just going to look at the item tap event, and we're going to bind the items property to a property called items on our component. And you can see that we get a template inside, and this is where we define the view for each row. And this creates a local variable item that is available to each template here, and we're going to bind to the title property of each item. So let's add our items here, and we'll just have 4 items. Let's add the onItemTap event. And we'll just pass an argument of E for event here. We could import a type for this event, but sometimes you don't know the type that gets passed in on an event. And in those cases, it's handy just to print out the properties on that event. And we'll just print out what the value is. Let's look at both on either platform. We'll see that they do look similar. What is interesting about iOS is that it has a max height by default, and so we're going to want to adjust this. And if we tap on an item, we can see that we get all the keys that are off of that event that gets passed through. It is the item tap event. We actually get a reference back to the list view object, and we can see this index comes through, and it tells us exactly what index we tapped on. There we can see index 1. So we could grab and use that property if we want to access that object. Let's first adjust our height so it's correct on iOS. For now, we'll just add an inline height attribute You could add this to the CSS class if you'd like. And if we look at that now, it doesn't look so great on Android, but it looks really good on iOS. We can see we got 100% list view height. NativeScript provides a way to deal with scenarios like that. So on iOS, we can prefix this attribute with iOS colon, and then for Android, we can use the Android prefix and say 75%. And now on Android, our list appears much better, and on iOS, we still have the full height. Because we have the power of Angular at our fingertips, we can also bind to observables. Let's import from rxjs. We'll use the behavior subject. Now let's convert our items to be a behavior subject. And let's actually use the items to set this up. We're going to reference these here, and we're going to convert this to a behavior subject. Be typed as an array of any type of object, and we'll instantiate it, and we'll initialize it to an empty array. And then to demonstrate, we'll just set up a counter that will just fire off an interval every second. And we'll take our behavior subject, and we're going to emit out a new array each time using an immutable data structure pattern. So we're going to grab the latest value of what's in our observable, and then we're going to append the latest item that's in our count, and then we'll just increment the counter. And for good measure, only if count is less than 4. Otherwise, we'll just kill the timer. Now let's bind to our items observable using Angular's async pipe. And we can see our list view now is just reacting to the changes on that observable automatically. You can install any number of NPM packages into your project. Let's install the NativeScript checkbox plugin. Interestingly, there is no checkbox component from NativeScript. And in fact, this is because there is no checkbox component on iOS at all. In these cases, NativeScript leaves these type of components up to the community. If we look at the NativeScript checkbox plugin from Brad Martin, we'll see exactly how that component will behave on Android and iOS. This plugin was designed for a vanilla NativeScript project. However, we can use it inside of a NativeScript for Angular project by importing from NativeScript Angular element registry. And that provides a method called registerelement. That will allow us to name the custom element that we want to register. In this case, we're just going to call it checkbox. And then we pass a function that is going to point to that class. And so in this case, we want to require our NativeScript checkbox plugin, and that provides a class called checkbox. Whenever using a custom UI component that may be coming from a plugin, if you're questionable on what the actual class name is, you can find the .ios and often the .android files in the root. And if you double check their implementation, you can see that they export a class. It is that named class that is going to be available to us as our UI component. You can see Android and iOS both export the same named class. And it is exactly that class that we are going to reference as our custom checkbox component. It's worth noting that you can register these elements really anywhere in your root component or even in the bootstrap file as well. Once they're registered once, they are available to be used inside of any NativeScript XML view here. Let's try out our new checkbox component. Let's drop it inside of the dashboard view. We can find an implementation example on the README, and we can actually copy and paste it as is, but we'll need to change a couple things. So first of all, there is no namespace with NativeScript for Angular, so we just registered an element called checkbox. So we can use that directly, and then we want to make sure that we close it properly, because again, with NativeScript for Angular, all your tags need to be closed properly. And then we don't use this binding syntax with Angular, and so we just want to convert these to just use Angular's binding syntax. Instead of binding to text, we'll just use a label here, and we'll call it custom checkbox. And for fill color, we'll just say blue. And let's just add our check prop as a Boolean initialized false. And when we run that, we'll see we now have a checkbox that has a nice animation. And on Android, we get the same nice effect. We can install the NativeScript dev sass plugin, and we'll save that to our dev dependencies. We can now set up our sass files. To start, we're going to rename this to .ios.scss. This is going to set up an iOS specific sass file, and we'll create an app.android.scss next to it. We'll now create an underscore common.scss file, and this is going to house the common style setup between our Android and iOS style sheet. We can grab the main import line from our original CSS file, and we're just going to customize this location to actually grab the light variables from the SCSS directory. There's also sky, blue, lime, and many different colors that set up the baseline variables you could base a custom style sheet on. One such variable is primary, and for this example we're just going to use white, and we'll customize the accent variable to be a specific dark greenish color for this vintage Christmas theme we're going to create. We'll further customize a couple more variables, our action bar background to a nice dark red. We're going to make sure that our action bar color, this is the text color, is going to use our primary color, which is white. And then we're going to set a secondary color and our button colors here. Lastly, we want to import the theme's main rule set. So these are all the classes that come from the core theme, and they will take on our variables that we customize above here. Now we can just use that sass file inside of our iOS and Android setups here. And then we want to import the platform-specific overrides. So there's a couple tweaks for iOS and Android that override a couple settings and properties for just those platforms. And this is in the sass platforms index iOS. And then this is where we could customize any CSS that is custom for the platform that we want to make. So we're going to make the same import in our Android file, but we're going to import this, of course, from index.android. It's important to note that when working with sass, the .android suffix is not the same as the .android or .ios suffix on these CSS files, because the CSS files are actually what is built in the NativeScript build. And that, because it runs through the NativeScript build, these are only picked for Android build, and then the iOS would be picked for the iOS build. But because this is standard sass, this is using a literal file name that exists in the sass folder. We're just going to set up a standard view here to actually use our core theme classes like button and button primary. And we can see that our Christmas theme is now applied to Android and iOS. Let's tweak a few more things. We want to add a bar separator, and let's set a top class on this stack layout and a vintage class here, so we can see more of our colors come out. And then in our common file, we'll just define those. We'll just give this a height of 30. And we'll use a background color, and we'll actually use an alternate of some of our themed colors. We'll define two extra nice colors, a Christmas alternative dark and a Christmas vintage. And we'll use Christmas alt for our bar, and let's set our top class to use the secondary background color. And lastly, our vintage class, which will use our Christmas vintage, and we'll just make sure it stretches full height. And now we can see more of our wonderful Christmas theme actually coming through. We want to adjust the status bar on iOS here to use white text, and we want to use a different tone on our Android status bar. Let's start with iOS and go to our app component, and let's import from platform. We want the isIOS boolean, and then we'll set up a constructor to only make this adjustment for iOS. And we want to import the topmost module from UI frame. That will provide us with the iOS controller, navigation bar, and bar style. And we can set this to 0 or 1. It defaults to 0 for dark text, and 1 will be our white text. And you can see our status bar text is now white. For Android, we need to go inside the app resources directory, Android, and inside the values directory. The colors XML defines this NS primary dark property, and we want to set this to whatever color we want our status bar background to be. In this case, I'm going to use an alternate of one of our theme's colors. So I'm going to take this AB background and just use a slightly darker version of that. And I'm going to get its hex code and use this color here. And you can now see this nice dark duotone status bar with action bar setup. Now let's say instead we wanted to use a very light colored background color. Maybe something around this range. You'll see that when using a light background color, you cannot read the status bar text very well on Android, so we need a way to be able to set this text to dark. To do that, we can go back into our app component, and we want to import star as app from application. And in our else condition here, we want to grab the decor view from app.android.startActivity.getWindow and the getDecorView method. And with that in hand, we can now set system UI visibility to the global Android view.view.system UI flag light status bar. And to silence our TSC compiler, we'll just declare that global here. And with that set now, you can see the dark status bar text on Android over a light colored background. To set up a live theme switcher in our app, we can install the NativeScriptthemes plugin, and we'll save this to our dependencies. To set this up, we can actually just require in the NativeScriptthemes plugin, but we need a style sheet to be able to swap into. So let's just create an alternate style sheet here. We'll call this blue, and we'll base it off of the light variables, and we'll just define a custom AB background, and we'll just set its color to blue. And then we want to import the main rule set. And now let's just create our blue.ios SCSS file and our blue.android.scss file. And this is just going to import our blue variable set, and we'll do the same for iOS. Then we want to import the platform specific overrides. This will be Android. So now we will have a blue CSS style sheet created and our base app CSS style sheet. And if we now go to our app component, let's just wire up a tap event to our button here that will change the theme. And we'll just wire that up here. And let's just set up a reference variable that will set active equal to our app. And to change the theme, we can just check if our active is equal to app. And if so, we want to change and toggle into the blue theme. Else, we're just going to change back into our default app theme. And then let's just make sure that we set our active. And to clean that up a bit, we'll just refactor this quickly. And if we run that now, we can see that when we click tap, that we get our blue theme. And when we hit tap, it resets back to the default app theme. Now you may notice that if we do a hard restart on that app, that it starts with the app theme every time, even if we had left our theme set to the blue theme. So it'd be nice to actually have the app remember what theme the user chose as the active theme. We can do that easily as well using the themes plugin, and we can check the saved theme by using themes.getAppliedTheme. And this takes an argument to set the default theme. So if there was not one set, we can make sure that it uses a particular one as a fallback. And so in this case, we will use app.css as the default. And if in fact there was a saved theme here, let's reuse our change theme to actually take a optional force argument, and we'll just call change theme with our saved theme. And we'll just change this to if force equals blue. With that in place, now when we launch our app, it will remember the last theme that the user selected. Here you can see from a fresh boot that the blue theme is selected.